This is slide number 2 of the course on Fourier Optics, and I am your presenter Asloob Mudassar. Here we present a different, we talk about physical systems. Our physical systems may consist of different types of lenses, for example, but mostly we shall be using biconvex lenses for imaging purposes. And the second one is that there could be the optical system may consist of different types of apertures. The apertures could be pinhole apertures, could be square apertures, could be rectangular apertures, or could be any type of slits placed in any part of the optical systems. Then you know that there are free spaces. So one component is separated from the other component by some spaces which we call free spaces. The light has to pass through the free spaces to reach to the other component in order to reach to the other components. Then we may have some special types of components, for example gratings, etc. And but you know that our optical system, the simplest one is will consist of a single biconvex lens, of course illuminated with some light, and then the image will be formed by that convex lens. We shall talking about these in greater details later on. Why Fourier optics? We apply the Fourier optics because the Fourier optics provides the best tool in order to analyze an optical system. When we say that and the designing of an optical system, so the designing is not possible unless we pass through a wave, unless we pass through some fields through the optical system. The field will pass through some objects, then it will pass through some components, as I mentioned earlier, which kind of components it should pass, and then of course the image will be formed. So the Fourier optics at each stage will provide us the tools for the calculation of the field. So for before an object, the field must be known, and after that component the field will be calculated. So the Fourier transform will provide us the tools in order to calculate the field at each and every plane in an optical system. So the best tool is the Fourier optics that would help us in order to design a physical optical system. And then of course the light sources that we shall be using with our physical systems, the light sources may consist of point sources, may consist of extended sources. So you see that the point sources and the extended sources may further be categorized as coherent sources or the incoherent sources. So the point source means, for example, if you put the tip of your pen on your paper, then that is actually just like a point. So if the point source means that the source having a very small dimension in comparison with the components that we are using in our physical systems. So the point sources are very small, and of course from the point sources perfect spherical waves are generated. And the distant stars, although they are many times bigger than our sun, they could be treated as point sources. Now the extended sources, for example, the laser may be treated as point sources. The extended sources, for example, the sun is an extended source. The light sources that we have in our homes and in our offices, they are the extended sources. Okay. Now these two types can be categorized as coherent or incoherent. When we say that it is, although we shall be talking about much greater details about these coherent and incoherent cases when we are dealing with the real physical systems, but here briefly I would like to mention that coherent system means that the waves are moving in step. That is, where we have the crest, each time we shall receive the crest at the same position, or we can say that the crests are moving in phase, that the troughs are moving in phase, or more accurately we would say that there is a fixed phase relationship between one point and with respect to the other points on a single plane. So you see that if we have a wave front such that it has the relative phases are constant on such a plane, then we shall say that we are talking about the coherent wave. And then you know that incoherent means that the phases are mismatching with time. So one time the phases are relatively changing with respect to each other on a single plane. So if we have a single plane, the light is incident on that plane, and if we observe the phases of these one, the phases will change randomly. Then we say that our source is incoherent. Okay, the profile of these waves could be spherically converging, could be spherically diverging, could be plane waves, or the combination of these waves. Mainly we shall be concerned in our Fourier optics course with the two types of sources, that is the spherically converging sources and the plane waves. So these two sources will be very important for us in order to analyze our optical system. Mainly the most important will be the plane wave. The plane wave normally incident on an optical system. We shall be talking about this sentence again and again and repeatedly in our course on Fourier optics. So here we ends our slide number 2.